So today we're going to be talking about the reality of DIY Kubernetes versus PKS. I created this because I deal a lot with open source, as my title would kind of allude you to. So I'm an open source technical product manager at VMware. My goal is to focus on all things open source that are kind of underneath the VMware umbrella. And of course, one of those that we are a huge contributor to is Kubernetes. And so knowing how to install, manage, and be able to create Kubernetes clusters the open source way is a crucial part of being able to understand the value that you get with paid for type of supported applications, glorified installers, whatever you want to call them. Just to give you a little bit more about my background. So I'd mentioned I already worked for VMware, open source with inside a Cloud Native Apps business unit. I've been working with VMware technologies for about a decade and a half. It started with around ESX 3.5, started going a lot of stuff down with vSphere, got bored with doing vSphere, got into software development led me into containers, and then containers ultimately led me back into VMware. So it kind of came full circle there. On the open source side, I'm also part of the Kubernetes release team. So anything that you've seen, at least for the past year, the past 4 releases, I've had some sort of touch point into the actual Kubernetes release themselves. I've been the enhancement lead now for the past few releases. So any new features or anything like that that's going into Kubernetes has had, I don't want to say it's been gated through me. I don't want to sound like I'm sort of somebody with a rubber stamp by any means, but I have had the ability to kind of say yes or no that it is going into Kubernetes. So if there is something that you want to be more involved with inside of Kubernetes, of course there are SIGs, the special interest groups, and that's a great place to get started, because if you're a big fan of storage or networking or even VMware has their own SIG, you can go and be a part of it. It's always great to get user feedback, customer feedback, and things like that. And if you want to be a part of the actual release team, there's other things besides just enhancements. There's release notes, there's the release lead, there's CI signal, all kinds of different things that actually go into developing a Kubernetes release at the end of the day. So I'm not going to bore you with some of the first slides in here as we just kind of talk about containers, because I think you're here for a reason, because we're not here to talk about virtual machines versus containers or anything like that, but we're just all excited about containers and really what does this seem to look like. And we all know what Kubernetes is. We know we focus on the orchestration, and this is, in a nutshell, what the Kubernetes architecture kind of looks like as well. Does anybody not know what the Kubernetes architecture looks like? Needs a quick overview? Okay, I figured most people, okay, we got one hand in the back, so I'll just kind of run through this really quickly. So just the Kubernetes architecture at first is, you're gonna have a master component. This is all a master worker relationship. So the master component is gonna have a lot of the different services running that are gonna be doing a lot of the container orchestration. It's gonna have your controller manager, it's gonna have the cloud controller components, and this is what's saying, this is how I hook into my particular environment, whether I'm running on top of AWS, or on top of vSphere, or on top of Azure, or anything like that. And then from there, you've got your worker nodes. Your worker nodes are the ones that are responsible for actually running all of the actual workloads themselves. And there are a few different components that are based in there. Of course, you need some sort of container runtime environment to actually run those workloads. For better sake of an argument, we usually see Docker almost everywhere with this. And then you've got 2 other components in there. You've got the kubelet. Kubelet is kind of like an agent for Kubernetes that is going to be doing constant communication back to the API server. It's also the one responsible for spinning up a lot of the processes or the containers or the pods with inside of those worker nodes as well. You've also got kubeproxy, which is going to be responsible for doing your TCP, UDP, SCTP kind of transmission back and forth from the container to whatever kind of services it wants to connect to. So that's a big, just high-level overview of this. And of course, on part of the master components, you've got etcd. Etcd is kind of like your database for Kubernetes. That's what's going to be keeping quorum of the cluster. This is what's really going to make sure that it has the state of what's happening inside of there. And there's lots of ways that you can look into this and how to build it, and we'll kind of talk about that as well. And so, of course, running a lot of these kind of different components, if you were to do this on a bare metal environment, Kubernetes brings a lot of different value that you have into this. So, if you're looking at doing things with just containers, it provides a completely container-centric management interface. At the same exact time, you've got the ability to kind of have automated scaling if you're inside of like AWS or something like that. One of the big things what containers really brings is environmental consistency. Knowing that I can create a Docker file or create an image and it's going to run consistently the same exact way across any type of environment that I want to run it. So whether I'm running bare metal or whether I'm running in AWS or running on top of virtualized environments, I know that that application is going to run the same no matter what. But when we layer this on top of vSphere, we get a little bit more things that are combined with it that make it a little bit more palatable. So kind of the same reasons that a lot of people went to virtualized environments to begin with, having the ability to have high availability and distributed resource scheduling to be able to move workloads as needed and as they see fit. You also have a single platform for all your applications, whether you are running containerized environments or whether you're running virtual machines. And we'll kind of talk about some of the announcements that came up during VMworld as well, which everybody has kind of been talking about a lot lately. You also have the ability to have abstracted network and storage virtualization built into this. One of the big things that VMware provides with storage interoperability is when you're looking at creating persistent types of applications on top of Kubernetes, you are kind of enslaved to what is available to you with Kubernetes. So you have the internal or in-tree type of drivers today. There's usually like the big 8. So you've got, AWS, Azure, vSphere, and a few other ones. However, really what's missing in that component is that if you're running in a bare metal environment and you're saying that I've got, I'm not going to call anybody out, but I've got a type of storage array that I want to use for Kubernetes, I can't because Kubernetes is not allowing any more in-tree drivers. So we'll talk about what that looks like here in a little bit, but vSphere, having that driver in tree as well as what's being developed out of tree is bringing our whole array of like thousands of supported storage backends to be compatible with running in a Kubernetes type of environment. So you want to learn how to build this, how to do this and build your own open source type of Kubernetes environment. And this is something that we all think, right? We're all engineers. We all want to read the docs, get our hands dirty, and figure out how to build it ourselves. So, of course, let's see what this looks like. One thing, if you start reading through the docs, and I'm going to show you exactly, these are screenshots from the documentations of Kubernetes, is that if you want to look into this, and this is going to be an overall theme as we start going through this as well, is that there's going to be abundant amount of choices. So if you're looking to run things locally, or in the cloud, or you want something turnkey, or on your own premise, like there's at least 3 years worth of bake-offs that are right here on this screen. If you wanted to sit there and try to figure out what's going to work best for your environment. And not only this 3 screenshots were taken probably, 8 months ago, maybe a year, something like that. It's just going to get more and more as this type of technology continues to mature. What are the ones that are out there that are ready for consumers to be able to start kicking the tires on day one versus if you want to actually go and develop it and try to build it yourself. And one thing before you get too bored, we're actually gonna build our first Kubernetes cluster through the command line today. So you're gonna kind of see this live demo happening as we get through this. So one of the biggest components that we want to see as we start building this, and it's one of the most critical tools, is Kubeadm, or Kubeadm, whatever you want to call it. What this does is this is a binary that's used that actually creates, it's what's considered to have a best practice or a fast path to creating this minimal viable cluster. Now, with this, it does this and it does this very well. However, it doesn't take into account other things for being, it's very agnostic to the type of environment that it's running into. It doesn't care if it's running on AWS or GCE or anything like that. So you have to kind of put in your own cloud special sauce in there. We'll kind of see that as we go and use this to build onto it. There's nothing that's being built into it for monitoring or management or anything like that. Just recently, they added the ability to do, upgrade. Well, actually, to say not recently. There's been about the past few releases the ability to do upgrades of your cluster through this. Just recently, they've introduced the ability to do multi-master It's still in an alpha state. And they've also recently introduced the ability to utilize Windows workers. So being able to take a window worker and add it into an existing Kubernetes cluster. So this is kind of the tool that was being built by the community for the community. It's one of the best of breeds that are out there. I'm sure that many people, if you had started down this path a year or more ago, you probably heard things like COPS or KubeSpray or all these different kind of things that are out there, which they're still fine, they're still available. However, everybody's kind of looking at Kubeadm as one of the proponents, or one of the components that are gonna be moving forward, what everybody's gonna be kind of relying on. Because above Kubeadm, there's another project that's being spun up called Cluster API. And what Cluster API is able to do is when we start talking about actually doing infrastructure provisioning based on Kubernetes. And Cluster API utilizes Kubeadm underneath the covers to do some of this provisioning of actually making Kubernetes clusters, but directly talking to infrastructure itself. So you're going to see a lot of these things start bubbling up, but just know that Kubeadm is one of these baseline tools. Not only that, the idea of actually creating Kubeadm is because if you go out there and Google it, I'm sure everybody's heard of Kubernetes the hard way. If you haven't, go and Google it. It's a great GitHub resource. If you really want to have a painstaking time beating your head against the desk, it's fantastic for that. But it was built because there's a lot of things that go into it. I mean, there's certificate creation, there's TLS sharing, there's all kinds of things that you have to do when you're creating your cluster, and Kubeadm simplifies a lot of this as you're going. So just kind of look at this as one of the main tools that we're going to be utilizing when we're building our Kubernetes cluster here. Now, another part of this is when we start looking at the beginning. We want to start building a cluster. Where do we start? I'm usually talking to a bunch of vSphere administrators in the room. Most of them know what it takes to actually have like a golden image. Once you have that golden image, we can start layering on the components of the packages that we need to make sure that we can make everything usable, right? And so we choose our distro. Of course, Ubuntu, CentOS, CoreOS, SUSE, RHEL, whatever it is that you want to use, it's perfectly fine. There's other ones that are more tailored directly for Kubernetes and container runtime. So you've got Rancher, you've got another one that was announced a few months ago called Talos, and I'm sure, as you can imagine, there's going to be more that are going to be continuing to come through here as well. And if you go and you just Google this, you can see 286,000 results for just which distro for Kubernetes. But when you get down a little bit further, is like, how do we make our template configurable, or our AMI, or whatever it is that we want to be able to do here? There's going to be countless blogs that are going to be outdated, because if you're looking and saying, okay, I'm going to use CentOS 7, and I'm going to use the latest and greatest Kubernetes with 1.16.1, let me go and Google it. Is this available? No, but there's one on CentOS 7 with Kubernetes 1.11. Odds are it's already outdated. So making sure that you can keep up with this trajectory is also pretty hard as well, because Kubernetes releases on a once a quarter cadence, right? So every quarter, every 3 months, you're going to have a new dot release of Kubernetes that's coming out. So keeping up with this is also going to be pretty hard. Making sure the template's going to work with your environment. Are you using a cloud-based image that relies on DHCP, or can you use static IP addresses? Whatever it is that you want to be able to do. And then you always have to fall back on your security and process and procedures for what's it take to make sure that these templates continually stay updated as well. And then you figure out, well, how far do I really want to go? Do I want to install Docker? Do I want to install the Kubernetes components? Do I want to be tied to that? That has to be figured out for yourself. You can introduce things to be able to do configuration management after the fact, but that's just something to try to figure out on your own and for your environment. And I'll kind of show what that looks like as we start going through these bash scripts that I hacked together. And then sizing. Sizing is a huge one. If you go, your mileage is going to vary with sizing. It doesn't really matter what you're trying to do, whether the application you're trying to run, it's just going to be based on experience. And so if you haven't tried running Postgres in a highly available way that has multiple containers that are spread out during different hosts, you have no idea what that size is going to be. And so you can't really rely on a lot of things that are out there to figure out, well, what is going to work well for my environment. So your mileage is going to vary on that one for sure. And then next we look at installing Kubernetes. What container runtime do you want to use? I see we have a Rocket fan right here in the audience, right? So I'm sorry, but it's no more, right? They've kind of said toodaloo, right? No more really supporting on Rocket, anything like that. But you have something that happens with inside of Kubernetes. The great thing about it is that it's a pluggable type of framework, a pluggable type of system, right? So utilizing Creo or a container runtime interface, we can take any kind of container runtime and we can pop it in there. We can see the same exact thing for network and for storage when we get there as well. But it's just one of the things that make Kubernetes super flexible and be able to be customized for exactly what you want to do or what you want to make it do. The other thing is, who's ran Docker in production? It's okay, don't be shy. If you ran Docker, okay, I see like 5 hands, right? So if you're running Docker in production, there's things that are going to be lessons learned as you're going through it. So you got to think about log rotation. How often are these logs filling up for these individual containers? If we rewind the clocks back 2 years ago, we think about which storage driver we're going to use. But today it's really like overlay FS. That's all we care about, right? But these are the things that we have to think about. If you've never done it in production, what are those types of parameters or configuration settings that we need to set to make sure that Docker underneath the covers of Kubernetes is going to be running just fine. And then what container version is going to be supported? This always just goes back into keeping a never-ending list or matrix of saying like, is this compatible with this, so on and so forth. So if you start looking and you start trying to figure out, does the latest version of Kubernetes work with the latest version of Docker? It doesn't always work out that way. However, on the Kubernetes documentation, it will have a list of supported Kubernetes versions along with a list of supported Docker versions and if they work, vice versa. So make sure you take care of that if you are going through here. And then what happens after you do a yum install, right? If you're a bad administrator, you're not going to do anything about that. And then what's going to happen if you do yum update? Right? We'll kind of look at that when we go through the scripts here as well. Now, architecturally, when you're building out Kubernetes, there's a lot of things to decide as well. Do you want a single master? Do you want multi-master? Now, people think all of a sudden, like, I've got to have multi-master. Why wouldn't you have multi-master, right? It's more high availability. But, if you're running in a type of like a virtualized environment on top of vSphere, it doesn't really matter if we need to add in those kind of complexity, right? Because you can rely on things like vSphere, HA, and DRS to migrate workloads if that's the case. Now, however, if you think like, that's fine, I gotta have multi-master, you can still do it. Then comes other things of thinking like, what about our etcd services? Do we do them stacked, which means that we install them on the master components themselves? Or do we create a separate etcd cluster because I've got somebody in my organization that thinks they know everything about etcd and they want to manage it, right? If you look at the Kubernetes documentation, it actually calls out and says that for a production deployment, you should have a separate etcd cluster. Now, I think that is up for debate if you want to actually do it stacked or separate. For the most part, 90% of all the deployments I've seen or I've been a part of have all been stacked, right? Just because it makes it easier for management at that point. So it's kind of like a choose your own storybook if you're reading through the docs, right? Like, do you go single master? Do you go multi-master? And if you go the multi-master route, you've got an extra 42 steps that you have to configure before you get ready to start installing anything because you've got to configure load balancers in front of it all for different types of services. You got to have DNS set up. There's certificate sharing, TLS, everything else like that that needs to be taken care of to do a multi-master type of setup. All right, networking. Yes, there's still more things to figure out here, right? The abundance of choices is going to be endless as we go through here. So this is a screenshot from the Kubernetes documentation itself. So as you can see, there's 8 different open source versions that are available to us. I can't tell you which one's better than the next, right? This is all for you to decide yourself. So if there's an advantage to having something like layer 2 versus layer 3, or if you think Cilium has better performance for your applications and so on and so forth, there's different types of things that for you to figure out if this particular pod-to-pod networking construct has to work for you. Why am I talking about this as well is because with inside of Kubernetes, you have to have some sort of overlaid networking that satisfies communication between pods within inside of the cluster. This also satisfies the communication from a pod to a service, and that service to an external network of actually how you can communicate from my computer down into Kubernetes. right? So there, you do have to do some sort of networking choice as you go through here. As you can see, these are just the open source versions. If you wanted to start looking at all the paid for versions, again, there's your next 2 years of bake-offs, right? We talked about Kubeadm already. So one of the things that you do with inside of Kubeadm is that you do an initialization to actually get the process started. And each one of these solutions requires just a little tweaking when you do this Kubeadm initialization. So we'll see that as we go through here as well. If you're also going through the open source route, you're going to try to figure out a way, if I want to operationalize this, how do I troubleshoot it? How do I manage it? What tools do I use? Well, it's open source. There's probably not a whole bunch of tools that are available because how do people make money? Well, they charge for tooling sets for their open source services, right? So a lot of these companies have some sort of tooling or interfaces or something like that that are usable to be able to have sort of that availability for troubleshooting. And scaling is another big one. I don't know how big your environment is. You don't know really how big it's going to grow on day 1, day 2, day 60, whatever it is. And there's not a whole lot of documentation out there that it says like, oh, Canal will scale to 10 million containers. That's a completely arbitrary number. I'm making this up, right? But there's really not a whole lot out there that says like what each one of these are capable for. So again, just more things to start figuring out what is this going to look like. Whoop. Okay, we're good. So onto storage. So we're not ready to install just quite yet. So as I had mentioned before, there's a lot of changes that are happening right now inside of Kubernetes. So one of the things that is the biggest push right now is to de-vendorize the core of Kubernetes. And by doing that, you're ripping out all the AWS components, all the vSphere components, Azure and OpenStack, like you name it. All those, they want to rip everything out. And then when you do that, you create this pluggable architecture around it. And when you create this pluggable architecture, it does a few different things. One, to say that, I'll pick on VMware here a second. So say we've got a problem with our in-tree driver, and we want to do a bug fix to it. Well, our ability to fix that bug is gated by the Kubernetes release cycle. We can't fix it for another 3 months, right? Now, when you take that and you take it out of tree, well, you create your own release cycle, right? You can fix any kind of critical vulnerabilities. You can add features. You can do whatever you want on your own release cycle. So taking everything out of tree is going to make that a lot easier. Now, you're seeing this not only just for storage, but you're seeing it for networking's pretty much always been out of tree, but you're seeing it for the cloud controller as well. So storage and the cloud controller, the two of the biggest components you're seeing of those being ripped out of the core Kubernetes right now. But this is a continually evolving process. So one of the things that I didn't talk about in the last slide, this is using something called CNI, or the Container Networking Interface. Storage is using, as you get to newer types of plugins, is called CSI, Container Storage Interface. Really, really good branding, right? But like I said, this is what's creating that pluggable type of architecture. As you start going down this path as well with looking about how do all these different types of environments, how they're configured, how are they treated for day one operations or actually getting these spun up. There's not a lot of good documentation out there. I'll be the first to admit it. Even VMware's is absolutely terrible, right? That's why we have blog posts that we point to people to instead of our own documentation. That's because everything's going through a major shift right now. And so even one of the best examples with Kubeadm, for example, I'll show you Kubeadm with vSphere in a little bit, actually be able to use Kubeadm with the AWS providers was then actually not on AWS's website of how to actually get it done. You had to go to Scott Lowe's blog to figure it out, and he's actually an employee of VMware. So these are one of the things that you see, that this is a type of ecosystem that is moving very, very fast, and it's hard to keep up. But like I said, it's something that documentation will get better over time. It's just how fast do you want to move along with it. And then, of course, if you're trying to figure this out on your own, there's all kinds of flags of making sure the kubelet knows how to talk to the right cloud provider and everything like that, that aren't necessarily always called out the best with inside of the documentation. So what's the first place I would tell you to go look for? This is a great resource if you're running vSphere and you want to learn how to build your first Kubernetes cluster from scratch, which I'll be able to show here using my series of hacked together bash scripts. But what he does is actually utilize a Ubuntu image using 1804. Of course, this is relying on DHCP. For the demo we're going to be showing here today is running as CentOS 7, so it's using static IP, so I'm not using number 1. However, number 2 is where a lot of the good juice is here. So if you go into here, this is where you figure out how do I set up Kubernetes using the vSphere cloud provider, utilizing Kubeadm to do my deployment, utilizing Flannel as a networking layer. And from here, this is for you to be able to learn and figure out if you want to automate it from here on out. Number 3 is actually utilizing the vSphere cloud provider to create volumes. This is creating your storage classes, persistent volumes versus volume claims, so on and so forth. I'm able to do that. And then, of course, I've got my link down here, so if you want to get my scripts, you can do that too. All right, so let's head on over to the first demo here. I'll pause that in that. Can everybody see that? I'm assuming you can. I tried blowing it up. So what I'm going to do is I am going to kick off this process. Everybody can just do me a favor and stay off the Wi-Fi. So what I'm going to do, as you can see, I've got 1 master and 2 workers here. And as that's going, I'm going to kind of read through exactly what this looks like, right? So this is the bash script on how I am creating my first master, and I'll kind of show how I'm doing it with inside of the worker as well. So first, I'm just updating the packages. That's going to take a few minutes. Next, I've got to disable swap. Why? I don't know. It's in the Kubernetes documentation. That's all I can really tell you. I'm also a terrible administrator. I don't want to figure out what ports to open, so I said, screw it. Let's just disable the firewall. Don't do that in production. Next is actually setting SE Linux to permissive, and at this point I feel like, okay, my housekeeping's done. I'm ready to start going installing some of the components here. So next I want to start installing Docker. So a lot of this is taken directly from the Docker documentation itself on how to install it in a production type of environment. So I can see that I'm installing the pieces that I want. As you can see, that one on the very far right is the one that's going to be coming into hand here in a little bit when we do the plugin version lock. But now what I want to do is I'm going to install Docker. I can see that I'm using 18.06.03. That's the supported version for the Kubernetes runtime environment that I'm going to be running here as well. When I talked about doing the Docker and production type of scenarios, this is where we're going to do log rotation. This is also the storage driver that we're using too. So overlay 2 is pretty much the gold standard now. Don't know why you would use anything else. You might remember the days when we used to have like religious debates on like Btrfs and overlay FS. And is anybody else around for those days? No, but anyway, I'm just trying to reminisce. So next is we're actually creating the Docker service. I'm sure everybody knows here how to create a Linux service themselves. So we start the Docker service, but now what I'm doing is I'm doing this plugin version lock. This version lock is very important because I had mentioned if I'm trying to be a good administrator and if I want to come in and patch security updates or do package updates or anything like that, and I go and I do a yum update, I might accidentally upgrade Docker without me really knowing it. So making sure that I put a version lock on it is gonna ensure that my hosts are gonna make sure they're not gonna be upgraded for this Docker particular version here. Next, going into Kubernetes, I'm adding in the Kubernetes repo here, and from here I'm downloading these different components. So the first thing I'm doing is downloading the kubelet. Kubelet's gonna happen on the master as well as the worker. Kubeadm is going to be our binary that we're going to be utilizing to actually do all the provisioning and bootstrapping of the cluster. And then you've got kubectl. Kubectl is how I interface or how I interact with my Kubernetes environment. That's the command line interface of how I provision deployments or pods or anything like that. Now I want to enable the kubelet, start the kubelet, and then I'm going to also put a version lock on these as well. Here's the network stuff. Now I call it network stuff because if I'm actually going to be utilizing Flannel here, so going back to if you want to create your own Kubernetes cluster, read the documentation first, because when you start looking at the open source versions, there's usually some kind of prerequisites that have to happen beforehand. This is the prerequisite that's called out by Flannel. Why? Hell, I don't know why, but I do it anyway. So it's there. So next after that is when we start getting into our vSphere configuration file. This is what's going to be utilized by Kubeadm to actually provision our cloud provider configure our cloud provider so it can actually talk to vSphere. So I can see it's my user, my password. If I was, again, a good administrator, I probably wouldn't give the keys of the castle to the administrator for this, right? I'd probably want to create a different type of for role. At the same exact time, I can see my virtual data center. Here's the data center that I have access to. The default data store. This is actually kind of important. So when you go through here, today, the entry driver for Kubernetes only has access to a single data store, right? Not a data store cluster or anything like that, just a single data store. So keep that in mind when you're going through here. The other thing that I found interesting going through here is actually figuring out my folder structure for resource pools. I'll give you an idea of what this does look like, because within here, this is the environment that I'm running in right here. This is my resource pool structure. It took me about 3 weeks of testing and trying and failing and doing it all over again just to figure out that's the folder structure for what that looks like, right? So again, not a lot of documentation on how that works, but if you want to know, now you know. The other part of it was that I had to specify a folder. Now, the folder comes in here when I see that I actually have to create a folder inside of my vSphere, my vCenter environment, and those virtual machines that I'm using inside of Kubernetes have to be mapped to that particular folder. Again, this is just a part of it being part of the entry driver and what it's expecting. So we set our SCSI type, our network on how they're communicating to the outside world, and we're off and running. Next is we are putting our initialization file here. From here, what I'm doing is I'm just creating a bootstrap token of how they're all going to talk to one another. This is just blah stuff, it doesn't really mean anything. I can put any kind of mixed bag of characters in there to make it work. From here, I'm also specifying the vSphere configuration file where it's at as well, specifying as well as the Kubeadm cluster configuration for my particular cloud provider, and I can see that. And then this is another critical part when you're looking for your networking pieces. This is the subnet, this is the pod subnet that's utilized for Flannel. So depending on which one you're choosing, that's actually going to change. So whether you're using something else, that internal subnet could be different. By default, this is what Flannel expects to see when it's being provisioned. Then I'm restarting the kubelet, pulling the images, so on and so forth, and we should be good. So let's see where we are with this. So we can see that this worker's ready, this worker's ready, this master has been pretty much provisioned here as well. If I go up just a little bit, I'll see exactly where Kubeadm starts. So we can see this is network stuff done. And I can see that right here, I am starting to pull in all these different components for the kube scheduler, everything like that. Just generating all my certs for me as well. Here's my kube config, doing everything like that. And right near bootstrap, tokens created, off and running. So we should be good. So let me go back to my, my cheat sheet here. So now that I've done that, what I'm going to do is I'm going to deploy Flannel. Just to make sure you don't blink, it's done, right? So that's how fast it is to actually just install a overlay networking component within here, inside of Kubernetes, right? So very fast on how that's done. I can see if I want to check on my pods, I can see right now almost everything's up and running, just waiting for core DNS to get spun up here as well. And what I want to do is I want to export some of this data out into what I call a discovery file, and this discovery file is going to be shared to my worker nodes. So I'm going to go ahead and push this over to my worker nodes real quick. Do it to the next one. All right, and so what I'm going to do, come over here, I can probably see that. There we go, there's our discovery, it's already there. And so now what I want to do is I'm going to join this to the cluster. So if I come over here, I can say kubectl get nodes. So I can see that right now I only have the master available to me. I'm going to go ahead and let that start. And then I'm going to do the same thing over here. So you can see what it's doing. It's automating everything that you would have to do manually of creating your certificates, talking to it, doing a match to be able to share the TLS encryption and everything like that back and forth between the master and the working components here. And at this point, we should be able to go back to our master. We're not going to be ready yet, but we should be able to see that we are creating our first cluster. It takes about 40 seconds for them to finally be ready, but as you can see, this is everything that it's taken from this point to actually get our first cluster up and running, right? Nobody's amazed. I love it, right? So as you can see, this is building it the open source way, right? This is building it, taking it from absolutely nothing, taking this, all these bash files that I created, and actually having something that I can work off, and I can automate it as much as possible as I'm going through here. And we can see that we now have a completely ready 3-node cluster for us ready to go here as well. All right, so let me kind of come back here. To what now? To the, don't worry, they'll be on the later slide. Or come to me afterwards. I'll be able to share that for you. So this is kind of a workflow or an overview of kind of what this looked like, right? So we're creating it ourselves. We create our master VM. Here's all the steps on what we had to do. Create the worker VM, and then we have to do this every single time that we want to do this. At the same exact time, we have to also think about, okay, this was fun, right? As an engineer, this is what we love to do. We love to build stuff. We love to see it work. What's the part that sucks? Maintaining it, absolutely. Everything else, right? Everything for day 2, right? So you got logging, you got monitoring, dependency management, keeping those matrices of everything that actually has to work here, so on and so forth. Security processes, I just showed you like probably the worst security of building this, right? Like nothing was taking in, of course the firewall is disabled, right? So that should give you a first thumbs up on that one. The second part of this is there are actually Kubernetes security hardening guides out there. None of that was taken into account as I was going through this as well. So these are a lot of things that you have to think about as what's going to be available for your environment, or what do you want to build into it. As I mentioned, Kubeadm is able to do upgrades for us. However, it is a touch point on every single one of those hosts to say Kubeadm, upgrade this host, whatever it is. So it is not easy per se if you have hundreds of these that you want to be able to do. Automated repeatability. So I showed you a bash script. You can try to repeat that as much as you can. However, it's probably not it's a very fragile way of doing it, right? It's very easy to break. We talk about automated repeatability a lot because one thing that we typically find when we talk to customers or go into their environments is that unlike a vSphere environment where you have 32 hosts and each host has a terabyte of RAM and crazy cores and stuff like that, and you're just packing tons of virtual machines on it, tons of computing power, you typically find pockets of Kubernetes clusters, right? I was in a talk here 2 talks ago, and they were talking about, are people asking for their own Kubernetes cluster? All your developers, are they asking for it? Yeah, we see that. And you could have this based on security boundaries. You could have it based on applications. It could be based on individual business units within type of your organization. So we see that the ability to create multiple Kubernetes clusters is highly wanted when you're going through and trying to figure out how do we continually do this over and over again. And of course, regression testing with all the different types of matrices in there of which one's going to be working with different versions. If we upgrade, is something going to break underneath of it? If we're running, not in a virtualized environment, how do I know my hardware is going to be compatible going forward? So on and so forth. And then going open source, where do you get support? GitHub, Slack, right? We always love that at 2 a.m. So you've got to kind of figure out where your comfort level is with that as well. So again, kind of looking at the core principles of what's going on here is that, as the trajectory goes and Kubernetes is released on a once a quarter cadence, you've got to figure out how do I keep up with each one of these different components that are always continually rapidly changing, right? This is my full-time job, just to keep up with everything that's going on in Kubernetes. I'm sure you all don't get to do that in your everyday jobs, right? So you've got to be reliant on somebody else to try to help them figure this out for you. Myself, we are also looking at spinning up a what's called an LTS work group inside of the Kubernetes ecosystem to figure out, like, is 3 months, is that the right thing to do? Should we have an LTS, like Ubuntu LTS? Like, should we have an LTS of Kubernetes going forward? Or should Kubernetes be like your iPhone where you just click update and then it's just, happens in the background, it's automatic, you don't have to think about it, right? So there's a lot of different thoughts that are going into figuring out, like, should there be an LTS, should there not be an LTS? So if you like religious debates, you want to be a part of it, come find me afterwards. And so when we look at the Kubernetes portfolio that's coming from VMware, we kind of see that we do have packaged options that are available to you. And of course, you get all the kinds of key benefits here on the side, but I'll just kind of quickly touch over what these are. So Essential PKS is the ability for us to help build it with you. What this does is this is an engagement where you work with our Kubernetes architects. A lot of these people came over from the Heptio acquisition, and they will help you custom build and tailor a Kubernetes environment for you. So they will walk you through and talk you through the different kinds of networking overlays, how should these be configured, so on and so forth. And so it's really a modular approach where you can pick and choose exactly which components you want. Not only that, is this type of offering doesn't have to run on vSphere. We can help you run it on top of AWS or any kind of cloud that you want as well, right? So that's one of the offerings that we have. Then we have Enterprise PKS. This is more like a turnkey solution. I'll do that demo here in a second so you can kind of see what that looks like. But this is more packaged, or should I say it's packaged with a lot more different software components into it. And so when you package in more software, you kind of know exactly what you kind of really, you reduce the type of variables or how many that are in there. And so you can create a lot more automation out of it, right? So you can just do kind of like one-liners to create a whole cluster, which will show you fun too. And then last, did anybody pay attention to the VMworld announcements that happened a few weeks ago? Raise a hand, a few. Okay, good. So Project Pacific was one of the big announcements that happened. Project Pacific is where we are going to be natively embedding Kubernetes into the vSphere layer itself, right? So making sure that as a vSphere administrator, you'll be able to operate and manage a Kubernetes environment just the same way as you've done before. So there's going to be a lot of talk and a lot of stuff that you're going to be building upon this probably for the next few months that you'll see. It's probably one of the most exciting things that are happening right now with inside of the walls of VMware, especially coming from the cloud native side, is to see this really transform and taking the whole vSphere install base and turning them into Kubernetes administrators as well. And so not only that, is making it all packaged and easy to be able to operate and manage at the same exact time. Tanzu Mission Control was one of those products that we announced at VMworld as well. This is sort of a UI that goes across all your private and public clouds. This is one of the projects that is heavily reliant on what I talked about earlier, Cluster API. So with Tanzu Mission Control, what it can do is it actually can ingest an existing Essential or Enterprise PKS, so it can look at health statistics and everything from the cluster in itself. But Tanzu Mission Control will also be able to take into effect Cluster API for AWS as well as Project Pacific and with vSphere, meaning that it will be able to automatically provision the infrastructure for you and be able to create the clusters themselves. Right? So that's one of the big things that you can kind of see happening here over the next few months as this starts kind of taking more shape. So just a quick demo of what Enterprise PKS looks like here. And when I say quick, I mean, y'all, we're gonna go real quick, right? So if I come here, I know it's really hard to see because I'm already keyed into a Windows machine. I already feel like I'm committing a sin already. But so when we're in here, we can see that we've created, or we have a cluster that's created. I can go to kind of just, we can see this right here. And then, so what I'm gonna do is, I'm just gonna say PKS, create cluster, my name, Kenny01. I'm gonna set the endpoint to Kenny01, that's typically a DNS name. And I'm gonna say I want 3 nodes. That's it, that's all it took. And then I can come over here to my vSphere environment. Just give you an idea of what it looks like. And hopefully here in a minute or two, we should start seeing some stuff happening down here in the tasks. So what this is using is this utilizes BOSH as one of the automation mechanisms underneath of it to actually talk to vSphere. At the same exact time, BOSH is looking at the environment to recover if anything goes down as well. So it's looking to see if, by chance, if a worker node is lost, it's going to go ahead and restart it. So it's keeping the heartbeat that's happening inside the environment. So as you can see, there we go. It's going to be off to the races. So it's cloning the virtual machines. It's going to be creating the network inside of NSXT. Again, when I talked about Enterprise PKS, it's bundled with a lot of different stuff. So of course, with vSphere being a core component of it, BOSH being the automation, NSXT is the virtualization layer or your overlay networking layer that's happening inside of here as well. And depending on how many nodes you want, 3 nodes, this will probably take somewhere around 30 to 45 minutes. So we'll just sit here and wait. I'm just kidding, we won't do that. But like I said, about 30 to 45 minutes, and you're gonna have your cluster up and running and it's ready for you. So like I said, quick demo on how easy that is to kind of get going. So we'll kind of wrap this up here, last few slides. So like I said, Enterprise PKS is one of those turnkey solutions. It's packaged with a few different things on top of there. One thing I do want to kind of talk to you about real quick, since I'm also a technical product manager for Project Harbor. If you are going to be creating containers inside of the walls of your own enterprise or your own business and stuff like that, and you don't want to rely on pushing stuff to Docker Hub or any kind of cloud or anything like that, take a look at Project Harbor. It has been it's now in the, it's past the sandbox phase of the side of the CNCF. It's now an incubated project. We're actually looking at putting this towards a graduated project. It's been there for quite a while now. We need a lot of things to get to graduated because this would be like one of 3 or 4 graduated projects in CNCF. Right now Kubernetes and Prometheus are the top 2. But there's a lot of different features that you get out of this container registry that you don't get with a lot of other ones that are out there as well. So you've of course got role-based access control. You've got things through OIDC as well as LDAP and localized databases. You have replication built into this as well. So you can have a centralized Harbor instance. It can replicate to other Harbor instances. It can also replicate to non-Harbor instances. So if you want to push and pull to Docker Hub or to Azure or Huawei or any other kind of just Docker registry that has been created, such as things like OpenShift, you can utilize that as well. It has an integration with Notary, which was a Docker project at one point. So if you want to do image signing in there as well. It has vulnerability scanning as a part of Claire. Claire is a project by CoreOS, so that's a part of this. So if you push an image to it, what it's going to do is it's going to scan for CVEs inside of that particular image. You're going to get a report of what this looks like. One of the new things that just released in 1.9 is actually having a CVE whitelisting feature. So if you want to set a threshold and saying like, I don't want anything running with a critical level of high within my environment, well, nothing's going to be able to pull from a Docker client to be able to run a particular image. But what you can do is you can say, I am okay running these particular CVEs inside of my environment, and now that Docker image can pull. I can also time bomb that to say, I only want the CVE whitelisted for a span of 2 weeks, because some of my engineers said that they could have this patch fixed in 2 weeks. So at 2 weeks, that image will time bomb, and they have to either get it fixed or upload a new one or whatever it is. There's also a new one with tag retention that was in 1.9. As everybody kind of knows that if you start building stuff inside of a CI/CD pipeline, you might end up having hundreds of different images or hundreds of different tags that are pushed in here. You could put a tag retention policy on a particular project, and inside that project, you can say that I only want to keep this image and maybe like tags like version 5 and version 4, and then versions 4,000 through 5,000 will automatically be deleted on whatever kind of cron schedule that you want to be able to set. There's also the ability, as I mentioned, projects. So namespacing is available inside of here as well. So you have an individual project inside of that project. You can upload images. It does Helm charts. It does all that inside there. And you can utilize any type of role-based access control to make sure that those users only have access to those particular images as well. Of course, audits, RESTful API, blah, 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 good stuff. It can also be deployed via Helm chart, a few different ways as well. Please go check it out, goharbor.io. So just kind of like some final thoughts here. So if you think about wanting to build this yourselves and figuring out if I can DIY Kubernetes on my own, what's the level of maturity? We all can't be Uber. We all can't have people just focused on making sure that this particular this type of technology is running and it's running really, really well. We're usually people that are, we wear a bunch of different hats. We got to be a jack of all trades, and we can't focus just on that. So what's the maturity that I want to be able to do, as well as the investment and time that I'm willing to make into it as well? And then, of course, inside of the PKS family over at VMware, of course, we have some of the packages. We have the expertise. Last I checked, I think it was a few days ago, we're the number 3 contributor to Kubernetes now. So we have a lot of the expertise inside of VMware. We're also contributing a lot. We were one of the main contributors behind Kubeadm, as well as one of the main contributors behind Cluster API. So we're really trying to push this forward. We see the value in what's happening inside the Kubernetes ecosystem, and so making sure that we bring, everybody that's always stuck in the virtual machine world and learning about containers and getting into this next phase is something that's very, very important to us as well. And then, of course, global support for the entire stack, up and down from the container down to your virtualized layer as well. With that, I think that's, oh yeah, if you want to get started, right, here's the last slides I was talking about. If you just want to get learning with Kubernetes, there's something that launched at KubeCon this past year called Kubernetes Academy. So you can go there. It's free resource, completely vendor agnostic. There's just tutorials on how to get started with Kubernetes, deploy applications, so on and so forth. So you can go ahead and check that out. Completely free resource that was just launched. If you want to build your own vSphere cluster, there's Play with Kubernetes, Play with Docker, stuff like that. You can get started there. This was the slide that I'd showed before. So the link at the very bottom is to my bash scripts that I had just had used earlier. So bit.ly/indk8s, because I actually presented this at a Indianapolis VMUG a few weeks ago as well. And then lastly, if you want to, you can go online. So there is an enterprise as well as an essential PKS hands-on lab. It doesn't actually say like Kubernetes, blah, blah, blah. It just says essential or enterprise. However, in each one of those, there are things that are tied to those individual product sets, but there's also things that are just completely agnostic, that are just Kubernetes only. So if you just want to learn how to create deployments, create pods, and all that sort of stuff, you can go and you can do that. You can spin that up. It's web access, and it's free to anybody inside of the VMware network. With that, thank you all so much. And if you have any questions, feel free to come up afterwards. Cheers.